Hi everyone! As you know, from geography, certainly, if you have not forgotten that, we have 5 oceans on planet Earth, but last year one rat made us discover the 6th ocean, the ocean of the remote or distance work. And all the companies embarked on building the fleet in order to charter these waters. In the upcoming 20 minutes, we'll look at the fleet of Yandex, which helped us to cross this ocean of remote and distance work. What usually is implied by OpenVPN? Usually, this is a kind of a hardware or some solutions by VPN manufacturers. If this is your case, then in spring you gladly accepted the help from your provider who helped you the VPN support to survive through the pandemic. So the lockdown is not over, although this is autumn already. The temporary licenses are no longer valid, but how you can do without licenses and extra costs? What if you use open source in order to get a good solution, a good fleet to charter through that ocean of work from home? In order to understand what a good fleet is about, let us define the criteria. For me, I have defined 6 criteria which the building blocks and the fleet for our scenarios should meet. First of all, no special hardware requirements. Regular servers are needed, just ordinary servers which are available from any rank-and-file shop. It should be open source. In order to kill 2 birds with 1 stone, first of all, you don't have to pay for licenses, and which is equally important, you can take original codes, and once you detect certain problems, you can remedy that on your own. And the solution which you need, sadly, should be applicable to all widespread OS, and Yandex, for instance, uses 5 of such OS. This VPN should run on UDP or TCP/IP2, these protocols. That's very simple. These are the 2 protocols which are most appropriate or infrastructurally more adequate in order to get through the firewalls which you may find in the airports or hotels. And it should be high-load solution, it should be robust and fault-tolerant or fault-resistant. And the last but not least, probably even the most important one, it had to be rocket-fast scalable in a linear fashion. Stop, why was speaking about OpenVPN by any means? Let's discuss that on chat. Now, you have the voting device. Tell me, how many of these points of 6 criteria would be met by OpenVPN and the OpenVPN-based solutions? And while you are taking these questions, let me tell you about myself. I'm working for 12 years in the telecom. I'm building data centers for Yandex, and I'm working for the market warehouses, so I'm present in almost all the networks of Yandex. I've left my footprints everywhere. Back in the university, I did not study the mathematical analysis, but dived into the computer science instead. I've spent a weekend to restructure our VPN so that the whole company could switch to the work from home mode. But nothing awful happened. Ever since, we didn't have any complaint about the problems with VPN which would deal with the infrastructure of the system. I think that we have all voted. It's high time for us to find out the appropriate answer. And sadly, all the 6 criteria out of 6 have to be met by the OpenVPN. Let us look in more detail how it can be done. Most importantly, OpenVPN, this is a process which works as a single thread server. So it means that at one moment of time, the OpenVPN can do only one action: to encrypt or decrypt the packages or identify the clients. And while it is doing one function only, other types of functions are lining up in the queue. Our main objective, our main target there is to make sure that OpenVPN spends as much time as possible on the processing of the packages. And we have to configure the OpenVPN the right way, make it right. First of all, make sure that your whole fleet, both the servers, the clients, this is very important, should work on OpenVPN 2.4 version. Why? Because they have the crypto which act as the counters. Without deep diving into the mathematical details, actually, you speed up your rate almost 2 times. And in TCM, actually, on mode, the OpenVPN would act 2 times faster. Sadly, it works in UDP. If you open OpenVPN website, there will be a very interesting article which in several paragraphs describes that.
And now we'll talk more about the server part, because clients as such are not of such a great interest to us now. Please make sure that you have IS Crypto Accelerator on your server, AESNI. Enable the VPN so that it works better with the socket, and furthermore, make sure that OpenVPN is fine-tuned for the processors, for the network cards, and all other features that you can find in any documents on high-load networks. And now about authentication. If you use certificates during authentication, and you should use certificates, so when you check them, please use the additional function of DIR. And furthermore, you need to ensure a basic DOS protection. For every VPN, you should have one certificate per device. There should be an individual certificate with its own individual serial number. In this case, if a device is compromised, you can ensure an employee's access via other devices. Furthermore, you will also be protected from DOS. You just use the OpenVPN patch that is available on this link, and then you can use this patch. Actually, it's located in the upstream of OpenVPN, but if you want it to be in the 2.5 version, you can ask the developers to do this. And now, regarding authentication, what solutions do we normally choose? Of course, it's all about scripts. Client connect, client disconnect, those are all our favorite things. Can we use them when the load is high? Obviously no. Why not? The reason is the same. While the script is working, OpenVPN waits for packets to be piled in buffers, and then the clients will see losses or delays. So what are the alternatives? There are 2 of them. The first one is to use management socket of the VPN. As a result, there will be a sidecar daemon talking to it, and there will be information on authentication exchanged. As a result, overhead expenses will go down. Furthermore, there is recently a plugin Subsystem which can be connected with a dynamic library, and the OpenVPN will talk to a certain method in a specific situation. I found 2 examples of how this plugin can be used. in these situations. The first one is a two-factor identification, but it only uses one method in the plugins. And the second solution is much more interesting, and it's done by a Russian developer. You use an embedded Python interpreter for all plugin methods. You can do this right on Python, and we really liked this idea, and we decided to use it in our environment and to fine-tune it a little bit. This is how we launched the Yandex plugin VPN. It also has a Python interpreter, which is initialized upon OpenVPN startup and keeps running, saving its context. It's all about the code, and it can speed up the things. If you don't need a certain method, you just don't include the relevant code, and the plugin will not include it in its work, and OpenVPN will not waste time. The typical plugin call uses the fork and give control back, and it takes less than 1 millisecond. Well, it's easier to see it, so we published it on open source. So please visit our GitHub, and you can use this plugin. I hope you will like it. So this is what regards our OpenVPN process settings. But what about the scalability, or the possibilities for this system to grow? As a rule, the speed with which the OpenVPN processes packets is not an issue. The bandwidth is not an issue. You can see that sometimes it works with 900 megabytes per second. I don't really believe that, but anyway, 200 megabytes are okay. But there's another issue. That's the time you need to spend on service data processing. And here is an interesting example. Let's suppose that the typical session of an OpenVPN client lasts 1 hour. What will happen during this 1 hour? There will be one authentication, one authorization, 4 re-authentication, TLS key refresh, and 1 disconnect. 7 events where we need our plugin. Let's suppose that we wrote it badly in Python, or maybe we address a remote server very far away. And let's suppose that every plugin call will take 20 milliseconds. What does it mean? As a result, the jitter for the clients will grow, delay will grow. And I really like the option where we have 60 connections, and there is the mean jitter of 2.4 milliseconds. That's the maximum that we could afford. We can't go any further. But if we have 7 plugin calls of 20 milliseconds and 60 connections per process, how do we ensure the connection of 20,000 employees? That's easy. We need to have more than 300 processes in OpenVPN. And for that, we need to load balance. Let's talk about load balancing. We can do this balancing incorrectly. For example, we can put all the 300 records of our servers in the DNS. It won't work. Not many clients are able to work with such a huge number of records in principle. But there is also a pretty unpleasant type of clients who are going to modify those records and change their order and so on. And we can also use an external load balancer. It's quite clear. There is good software and hardware, but this is yet another point of failure, and sometimes it requires additional hardware. Along with the load balancer, we can use Anycast. Anycast can't be used for OpenVPN for the same reason why we struggled with jitter. That's because this is another rerouting of your network, and as a result, the traffic can go to another server as a result. So how do we balance those pools correctly? We probably need to use our load balancer right on the server, per server LB, and we also need to use our clients directly by switching on the remote random option. This is a pseudo-random function, and as a result, the information will be distributed pretty equally between the servers. How do we use this local server load balancing? We can use a system which is called ipvs. That's for Linux. It's a pretty good system. And we can add some health checks to it. We can use some sockets that work with OpenVPN, or we can use the process so reuse port, which is used for the same socket. And there's another option, FreeBSD, or setSockOpt. So let's try drawing a little bit. Here, let's have 4 processes, or OpenVPNs, that use the same UDP port. To balance the loading in the core, a very simple hash function is used in this core, which distributes the input traffic based on the headers of the packets. The reverse traffic is not hashed, of course. And it may happen so that we have a failure in some process, or we can add another process, and then the hash function will change, and the packets that used to go to process 2 will go to process 3, and the clients will be disconnected. It's not very convenient. This is not what we wanted to have, which is why we prepared a small modification for this function. In addition to the hash function, we drew a table with the sessions, and this is important. When there is the first outgoing packet from the client, when the client sends you the packet, there is a record in the table, in the status table, and the following packets will be sent to the second process. And it's not based on the hash function, it's based on the state table. Of course, this patch is available in the open source. You can use this link and join our discussion there. But let's see what the client's configuration looks like if we use all those practices. This is what it seems to be like. In config VPN, we have a certain number of servers, and there is also the remote random option. And we also use DNS, and we write IP addresses for each record. And it would seem strange to talk about all those little things that we did to connect all our employees without mentioning what we really had in practice. Let's look at March. That's when our company started working offline 100%. These are the traffics from the users, and that's the weekend where I had to reset all the groups of our servers. So from Tuesday till Thursday, we had a triple capacity of our virtual servers. And this is what it looks like now. This is a geo-distributed cluster. The servers are located in different locations if there is a failure, no one will notice anything. There are 20,000 simultaneous connections. There's more than 20 gigabit per second throughput. It's scaled threefold within 5 days, and we can keep scaling it without any limits. We just need to add servers sometimes. So what happened at that weekend where everyone went online? Let's remember those sockets. We had 4 processes on those sockets. Everything I had to do to make 21,000 connections instead of 7,000 connections, I just added some more processes. And they used the same patches in order to build themselves into that group. So it was quite easy. When we did all those changes, it was obvious that we could simplify the client's work. Adding one server means that we need to amend all the configurations on all other servers, and it's very inconvenient when we talk about thousands of clients. So we added another patch which implements a standard mechanism. That patch is available. It was made available by OpenVPN developers, so you can look at it. We will be happy to get more feedback. So that's it. To conclude, I would like to thank my colleagues, without which 2/3 of my presentation would be impossible. I thank Mikhail Orekhov, Artem Rudenko, Andrei Laskov, Vlad Grishenko. Thank you very much. I would not do this without you. Well, was I able to convince you that OpenVPN can ensure all those 6 things? Please answer this question. As Andrei is getting the most interesting questions from the chat, I'm ready to answer those questions. Thank you. Thank you, Boris. Well, you can actually make a trolley bus out of bread, but why? You already have everything needed. So if you haven't asked your questions yet, it's high time to do that. And the first question to Boris: how many people ensure the work of OpenVPN at Yandex? Answer: well, we have 7 persons on our team right now, and each of them is involved in organizing those servers. But along with OpenVPNs, we also support all corporate networks, including those that work with the warehouses and markets. Thank you very much. There's another question. Well, we are looking at the alternatives of WarGuard. WarGuard is not a bad option, but WarGuard does not implement some of the functions we need. For example, it doesn't work on top of TCP. And for a big company where people have a lot of business trips or used to have lots of business trips, it's a very important feature to get connected to the VPN. But we are looking at Vanguard. We hope they will do this. So we wish them all the best. Let's wait for your presentation next year, right? Yes, let's hope for it. And there's another question from Vasily. Can we flood the custom connection table? Yes, we can flood it, but the OpenVPN is only responsible for clients who did authentication. You remember that I mentioned the disconnection of the VPN set option. So if you haven't provided your private key, the OpenVPN will not even answer. It will not even respond, so there will be no change in the status table. There is another question. All those Python plugins, are they really better than the standard methods? I didn't really understand your question because the Python plugins are actually needed to process all the fields correctly. and we need to ensure the split tunnel and the necessary radius. All right. A question from Megabytes. Mikhail, 5 megabytes, do you think it's not the best productivity? Well, it's enough for us. Fair enough. Well, let's wait for another minute. Maybe there is someone else who would like to ask their question. Let's wait for half a minute. Well, let's look at the results of our poll. Well, look at this distribution. 41% of respondents believe that VPN is capable of all 6 functions, and the others decided to mock at me a little bit, because the OpenVPN, as they said, is only able to process 3 functions out of 6. But this distribution is great. Let's look at answer 2. 55% of the respondents said that OpenVPN is now held in high esteem by them, and that they are ready to install OpenVPN right now.
One more question. Why stateful tablets? Why not stateless? Resembling, well, stateless implies hash functions, and if we change the number of servers or processors which are servicing such a load, then the hash function would change, and the hash value would change, and the client's session would just get out and go down. Okay, thank you so much, Boris. Thank you for your presentation. Join our chat. I do think that people will have more questions. You are invited to ask them on chat. Boris, thank you. Thank you.